Morning, guys. Thanks for joining us. Really, with base fertility and what we're talking about, we're going to go through a couple different ways of looking at how we need to figure out where to put our dollars when it comes to fertility, what's kind of our building blocks that we need to start with, and then some of the things that are specific to Southwest Iowa as far as yield limiting factors. So as kind of a guidance to this, these are all summarized data from myself, Kurt, and Dowd, and even our colleagues across the state of Iowa doing some of these soil sampling efforts to try to learn more about what builds yield for us with our hybrids locally. So to give you guys an overview, we've been actually sampling our corn PKP locations. So a lot of you guys have known that we've touted having one of the most robust research efforts when it comes to testing products in different locations across the state of Iowa and even in the Midwest. But at these locations, we're taking soil samples to figure out if we're at a 200 bushel yield level, what are the nutrients that make up that bushel yield level? What's a 250 bushel yield level and how that's built? So for you guys looking at this map, this is showing us all the different geographical zones that begin to pull out of our data set. So we're able to see certain factors that step out and are more important in different geographies. You know, as you look in the Western Corn Belt, irrigation could be key. pH could be a driver that changes some different things. For us today, we're gonna focus specifically on nutrient loads. So as you kind of drill into the state of Iowa, you can see we're kind of unique. For the most part, we act like a Northern Corn Belt region. And I'll dive into kind of what makes that up. But we also have some counties in our map that act a little bit more like a Western Corn Belt feel. So maybe have more of a feel like Nebraska, where we might have a little bit more of an arid climate and we have some different drivers there. But the most important thing to take away from this map is even though we have a number of different zones and that kind of appeal to us in Iowa, the nutrient needs are very, very similar when it comes to Western Corn Belt and Northern Corn Belt. So what that means to you guys though, is we need to work with our local pioneer reps when we're making recommendations for these different soil types, because they're gonna know what has more of a Western basis to it or what kind of coincides a little bit more with that Northern Corn Belt that stretches into Northern Illinois. So within that Northern Corn Belt, two big factors that play into yield are phosphorus and potassium. So you can see through our sampling efforts, phosphorus and potassium both play a huge role in driving yield. For us in Southwest Iowa, our native soils are a little bit better when it comes to phosphorus part per million in the soil. What we really need to draw our attention to is potassium. Some of that comes into play when we look at some of our higher yield levels that we're pulling off of these farms. We're taking a lot of potassium off those fields. The other thing is, do we really know enough about potassium? Are we losing some potassium through leachability and things that we haven't really admitted in the past? There's a lot of different factors that we have going on there. But one thing is for sure, potassium is a big driver in yield, and we'll dive into that some more. So really with this PKP sampling effort, we turned it into kind of a characterization. So within these environments that we're testing locally, we have a high, medium, and low yield level. And sometimes those high, medium, and low yield levels draw a very black and white line on potassium levels, phosphorus levels, where our populations need to be for high yield. And we'll dive into that a little bit more. But one thing that I want to get started into is how do we prioritize that? So you'll see this concept of the yield pyramid floating around. It was kind of started by an agronomist in Northeast Iowa by the name of Troy Deitmeyer. And really what Troy's trying to do is how do we prioritize the big things so we're not chasing some of these foliars and micros that we're putting on late in the season that aren't impacting yield enough for us. So what we may learn by the end of this conversation is instead of buying a micro pack that we put on with our post-applied herbicide application, we may want to look into what are the dollars that we could throw at another potassium application. Would it benefit us to make that potassium application every year before corn and soybeans? So really, guys, this is something And I'm going to put in a little note. April 2nd is another webinar where they're going to dive a little bit more into this yield pyramid and probably go block by block. For us today, we're just going to kind of focus on potassium as a main building block, but then also on the sulfur side because of the data that we're seeing here in Southwest Iowa on sulfur impacting yield. So one thing that I wanted to call out, and I touched on this earlier, guys, we're really seeing a strong correlation between potassium levels and high yield. So that's not to mitigate the importance of pH, drainage class, things of that nature. Phosphorus is another one that's in our building block and needs to be of high importance. But for us in Southwest Iowa, look at where some of these levels are, and it's definitely linear in their impact on yield. So as we look across, potassium is definitely one that we need to prioritize in both corn and soybeans. So here's just an example as we look at this screen, our low, medium, and high yield class. So you can see that we're down in the 170s, and then it's definitely a linear trend. It's not skewed all over the map. You can kind of look at some of these nutrients that are in these different boxes and see that there's a wide range of where they come out, and you're definitely not seeing that trend that correlates exactly to yield. But when we get below that 190 mark, our susceptibility of hitting 180 to 215 is a lot higher. And I know that's a very good yield, but look where we can draw direct correlations. When we can get our potassium to about 190 and even up into that 214, we're looking at a lot higher yield levels. That's when we're hitting the 230s to 250s. So one thing that we've kind of noticed is we have a lot of universities recommending maybe a little bit lower than what our pioneer reps are recommending locally. You know, we're recommending 30 to 50 part per million of phosphorus, and you can see we're hitting that pretty commonly at all yield levels, but it's where the potassium comes in that we're recommending anywhere from 200 to 250, which is a little higher than the universities, but from our data set, we're seeing big things with yield as we continue to manage potassium. So one thing I wanted to touch on before we just make everything correlated to dry P and K, pH is very important. So if we have a pH down in the 5s, our nutrient load is very less accessible to the plant if we're down below 6 pH. So if we can get in that 6.5 to 7, we make that so much more available to the plant when it comes to phosphorus and potassium. So that's key when we talk about that yield pyramid, getting that pH block in the right order so that we can access phosphorus and potassium. If we don't have that correct, we can put on all the nutrients we want, and it's pretty tough for the plant to access some of that. Another thing to kind of touch on, guys, if we're going out on a 2-year spread with 100 on a P and K application, and we're taking off 250 bushel corn and 70 bushel beans, we're starting to take a little bit more out of that soil reserve than we want to. So over the course of the last 5 years, our yield levels have been above that 150 mark, a lot of times hitting 200 bushel. We've seen some really good bean yields as well, but this is just a good slide to remember. With these yields, we're also removing a lot from the soil, and we need to replenish that so that year in and year out, we can still attain some of those yield levels. So as talked about before, we wanted to hit on sulfur. And so once we get all those big blocks in place, we have noticed here in Southwest Iowa that sulfur has kind of been the thing that has been that next hurdle for us as far as management. So a couple of things with that. With the Clean Air Act that went into place a few decades ago, we're actually not getting some of those acid rains that would actually supply us with fertility. You guys have seen that message pushed year in and year out. But the other thing is some of these yield levels that we're going for. So now that we are managing our big rocks, pH, P, and K, sulfur has become that limiting factor for us. So here's just a field study that was done in South Central Iowa in 2018, where they increased 17 pounds of sulfur pre-plant, and they saw some pretty big springs with that thing, 20 bushel and 40 bushel respectively. So They also did include some zinc in that application, but for us right now, we're looking at this as a sulfur basis. So that kind of got us down the trend of, hey, we need to look at sulfur a little bit more because of how limiting it is in some of these fields. So here's just a drone image of that field, and you can definitely see the cosmetic differences going on there. So then from 2018, we tried to make it a little bit more scalable. We actually went in and tested some impact studies with a number of different guys applying sulfur in different degrees with different methods and different commercial fertilizers. And we saw that there's also a strong correspondent with sulfur. Now, we didn't see as good of a yield response with the elemental sulfur, and there's a lot of different biological things that go into availability of elemental sulfur. So you can see a little stronger correlation to, some of those readily available nutrient sources. But basically what this did was confirm the proof of concept that we need to apply sulfur year in and year out. So what does sulfur deficiency look like? The intriguing thing about sulfur, it is mobile in the soil, but immobile in the plant. So what that means to you guys is it's very leachable like nitrogen, which makes sulfur a product that we need to apply every year because of that mobility in the soil. It needs to go on ahead of beans and corn. And the immobile part in the plant is the reason that we see so much of this neon green chlorosis in the field. It stays in the upper part of the plant because it cannot be translocated from some of that older tissue to newer tissue that grows within the plant. Now, nitrogen is a product that can be translocated. So a lot of times you see that firing from the base of the plant and we don't notice it until it's too late. Because of sulfur being immobile in the plant, we can actually make some applications when we see this deficiency start to occur. So on the bottom right is just a comparison that was made in Southwest Iowa. It was actually one of Chris Dowd's reps that he was working with there, where they did a ammonium sulfate split within the field. And much like the earlier slide in 2018, you can definitely see the cosmetic injury taking place there. So adding that field into some of our results that we went out and strip trialed here in Southwest Iowa, because of the dry year, the lack of mineralization within the soil, we saw almost 100 bushel response in a lot of these fields just to 10 pounds of sulfur applied. So it not only affected grain fill, but it affected pollination and everything when it came to kernel counts as well. So as we look at sulfur, it may not just be limiting in a wet year when we think of mobile nutrients really struggling. It can also be in a dry year where a lot of times we're relying on soil organic matter to mineralize some of that sulfur load as well. So here's just some local responses here in Southwest Iowa where we saw some really big things with sulfur. So how do we manage our fertility plan going forward? So if we think about nutrient factors and also kind of nutrient limiting factors, we can think of Liebig's law of the minimum. What is our most limiting stave? If potassium is a stave that's really big and important, if we're not managing that, we cannot jump over it for a soil micro to manage that. If we're looking at, hey, can I put on a foliar feed? If we do not have these other staves of the barrel corrected, we're going to have a leaky faucet there and we're not going to be able to maximize yield. Another way to look at it is get our big rocks in place first. If we want to fit our jar, our soil capillary with important nutrients, let's get those big rocks in place so that we can manage everything correctly. As we go forward and dive into sulfur a little bit more, a lot of times what I recommend is a 1:8 nitrogen to sulfur ratio. So if we're looking at, 200 pounds of nitrogen, a lot of times we need to be looking in that 20 to 30 pounds of sulfur as well. When I talked about organic matter affecting sulfur as well, in some of those lighter organic matter soils, we need to make sure we're applying more sulfur so that we can meet the need of that plant as well. I know a lot of my examples today talked about sulfur in corn. We're looking forward to doing more testing next year in regards to soybeans as well as just corn. But as we go forward, think about those big rocks and think about that yield pyramid concept.